All right. I'd like to start things off by introducing myself. Hello, my name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level who's involved in CTE training, a college professor, or an industrial trainer teaching programming skills required in manufacturing. Maybe you're a company looking for ways to demonstrate your software-based solutions, or even just someone who's looking for a way to make concepts, something like, let's say, IoT, easier to understand for employees or customers. In any of these cases, I do believe that this presentation is going to offer some important options for you to consider. Now, let's start off by considering the skills gap. Now, if you've attended any of our other fischertechnik education focused webinars, you've probably heard me discuss the importance of STEM education. And of course, STEM is the acronym that stands for science, technology, engineering, and mathematics. And it should go without saying that STEM education has been perhaps the most discussed topic in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help best prepare them to take their place in the modern workforce. Not so long ago, when our parents or grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing has become more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. And as it ties in with the solutions we're going to be looking at in this presentation, let's consider that last skill area that I just touched upon, that being a PLC programmer. Now, first off, for anyone who may not be familiar, let me explain exactly what a PLC is. Now, the term PLC is an acronym, and the letters stand for Programmable Logic Controller. And essentially, a Programmable Logic Controller, or PLC, is a very specialized computer used to control the types of machines and automated processes that are typically found in an industrial setting. And these are going to be things like an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems, of course, grows exponentially. Now, to get a clear idea of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from the job search website nuvu.com. To quote, the average PLC programmer salary in the United States is $78,000 per year, or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year. Now, in fact, a quick glance of the first page of current job openings for PLC programmers on nuvu.com, the date that I prepared this webinar, which was in early February of 2020, showed 15 positions being advertised with salaries of over $75,000, and 2 of which even listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. And at the same time as this workforce of tomorrow gets their training, more and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools that are offering programs like this. So how long does it take to learn PLC skills? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. Of course, to become truly proficient in all 5 of the most widely used PLC programming languages, which you see listed here, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, of course, more training than that would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are many other options available besides the college and university programs. There's high school CTE, career and technical education programs. There are adult continuing ed programs, vocational training, technical training and trade schools, and of course, as I mentioned, employer-sponsored incumbent worker training programs. Now, that all being said, The question that still arises for the educator, and that's whether you're in the university or the vocational school setting, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it more realistic and hands-on? But there are other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding the different aspects of automation and control systems. For example, it could be a company involved in the creating or marketing of a new type of software-based solution that's looking for a way to make more tangible processes which might otherwise be perceived as abstract, or to test it out in more realistic fashion. Or it could be a manufacturing company looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. It could be a company that's looking for engaging ways to demonstrate their services or solutions in a public setting, such as a trade show. Now, in each of these cases, and of course there are more, there's a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the fischertechnik line of industrial simulation and training models. Now, these models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate, in both appearance and in function, various automated robotic machines and systems that are commonly used in commercial manufacturing. But before we look at each of these models, I'm just going to provide you with a little bit of background. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, all based around their unique building system. Now, what makes their building system unique is that unlike other popular construction systems where the components are designed to simply stack, the fischertechnik system was created with more of an engineering mindset. The core building block in the system is designed to enable attachment from all 6 sides. Because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. And the hundreds of different parts available will also help to address very specific design needs. The fischertechnik system was created back in the 1960s by German inventor Arthur Fischer, who you see on the screen now, who is noted for countless innovations used in construction and the automotive industries. Now, Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides fischertechnik, Mr. Fischer is also known as the inventor of synchronized flash photography, and that was back in 1949. And he was also the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction. And they also produce numerous components used in automobile assembly, as well as providing high-end consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik building sets, and it's whether those intended for the retail market or for classroom use, has always been to help foster an understanding of technology and how things work. Now, many of the products offered by fischertechnik for the education sector are what we would refer to as subject-specific sets. And by that, I mean that they focus on different STEM-related areas, such as focusing on mechanics, pneumatics, robotics, or let's say renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique fischertechnik system. And then they're asked to perform various experiments which allow them to explore and understand the aspects of that subject. Now, there are also sets that are designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based learning programs, students dive deep into engineering and learning all aspects of the design process, which requires them to work in groups and create various devices and automated machines to meet the criteria being put forth in a series of real-world style scenarios, all based upon their own trial and error, experimentation, and research. Now, the line of fischertechnik simulation solutions, which of course is the focus of today's program, are something much different. The line consists not of kits, but of a series of pre-assembled small-scale models, which replicate, again, in appearance and function, the various automated robotic machines and systems. Now, models that you can find in the fischertechnik simulation line will include things like conveyor belts, punching machines, 3-axis pick and place robotic arms, color sorting lines, and high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. Now, this model consists of 4 individual workstations, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection that are designed to all work together as one self-contained material cycle. Now, before we begin to look at all these models in the simulation line in more detail, I'm going to very briefly outline some of the advantages of using fischertechnik solutions. Now, I will apologize in advance as the first few points are things I've already touched upon, but in each case, I do think it's worth repeating. First off, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this could be for understanding how automated systems work, or for having a tangible and physical system to observe and work with in a programming or PLC-focused learning environment. Advantage 2, the models are once again designed to realistically replicate in both appearance and in function common automated systems, things again such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases tabletop sized, they are not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. Quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each model, with one exception that I'm going to address later, is currently available in 2 different versions. The first version is a 24-volt version, which is designed for use with industry standard PLCs. Now, whether you use Allen Bradley controllers, Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or others, you can control these 24-volt versions with the PLC you choose. Likewise, just as you can use your choice of controller, you can also use your preferred programming language from the choices listed on the screen now. Now, please note that with the 24-volt versions, no PLC is included in most cases, and all programming and programming guidance, as well as any power sources or other hardware, in most cases are the responsibility of the end users. There will be an exception or two, and I will make that quite clear. Otherwise, I would say that I don't think this should be a big issue, as these models, again, are designed specifically for industrial users or for those who are already teaching and exploring industrial processes or PLC programming. On the other hand, for non-industrial users or for educators who are not versed in or familiar with PLC programming, in some cases, there are 9-volt options that are available. Now, these 9-volt versions will ship pre-wired to fischertechnik's own proprietary robotic controller, which is referred to as the Robotics TXT controller. And in this case, each controller is pre-programmed using fischertechnik's own RoboPro graphic programming software. Now, in the case of these 9-volt models, the only additional component required will be the addition of 1 or more 120-volt power adapters. And I will, of course, specify that when these things come up in the course of the presentation. Now, if you're involved in demonstrating or exploring IoT, also known as the Internet of Things, besides the fact that many high-end users have adapted many of the models in the primary line of simulation and training solutions for IoT purposes, fischertechnik now offers a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud control and what is often referred to now as Factory 4.0. Now, in this instance, the model is designed to be both controlled and monitored from a special web-based dashboard. We're, of course, going to get into this all in more detail a little bit later in the presentation. Moving right along, fischertechnik simulation models are cost-effective. Now, while I won't get into names, I will say that if you've looked at any of the other hardware-based industrial simulation options that are available in the marketplace, you've probably noticed that the entry point for many of these products can easily be $20,000 to $30,000 or even much more. Fischer-Technic simulation solutions, on the other hand, start at only a fraction of that price, as well as, again, being compact, realistic, and high-quality learning and demonstration tools. So with all of that being said, let's begin looking at the models which are available. First up, we're going to look at the vacuum gripper robot. Now, as you're going to see in this video, the vacuum gripper robot is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. The model itself includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you'll see in the video, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches, and it has a weight of just about 7 pounds. The 24-volt versions of this model, as well as the other 24-volt models we're going to be looking at and coming up right here, each have a relay board for motor polarity reversal and both a multi-pin connector, 26 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as with all of the 24-volt versions, will require you to provide the PLC and the programming. The 9-volt version, which is the version you see in this video, will once again come wired to the fischertechnik Robotics TXT controller and will ship fully programmed using RoboPro graphic programming software. Now, if you wish to create your own programming, individual licenses of RoboPro are available on our website. Otherwise, for this 9-volt version, only the addition of a single 120-volt power adapter will be required. I will mention that for this and all the other models we're going to look at today, the specs are also detailed in the products listing found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. Next up, we are going to look at the high bay automated warehouse. This model features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays in 9 individual storage spots. Components of this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces, along with carrier trays for each. I will note that this model is a favorite among educators I know who are teaching programming because it gives you a lot to work with in regards to the movements of the picker mechanism, as well as the precision required to properly store and retrieve each workpiece from the warehouse. Each step, of course, which requires its own very specific coding. The dimensions for the model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds. Once again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide your own PLC and your own program. A limited edition 9-volt version is also available at this time, which again is pre-wired to a pre-programmed Robotics TXT controller, and one 120-volt power adapter would be required for use. The next model in the line is the multi-processing station with oven simulation. Now, this model will feature a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of just about 11 pounds. Again, the standard version of this model is the 24-volt version for use with the PLC of your choice, with once again a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. The limited edition 9-volt version in this case is connected to 2 Robotics TXT controllers So 2 120-volt power adapters will be required for all operations. We'll just let this play out. And pretty cool. The next model in our progression is the sorting line with color detection. The simulation you'll see here features a system for detecting workpieces of different colors and sorts them via conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of just about 10 pounds. Now, as with the models we've looked at before, again, the standard 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you do need to provide the PLC in the program. And there is a limited edition 9-volt version, which again comes pre-wired to a pre-programmed robotics TXT controller, and in that case, one 120-volt power adapter is required. We will let this one sort through as well. And there we go. The next model we're going to look at is the factory simulation, and this combines the 4 models that we've just reviewed. In this case, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection, all being combined into one self-contained material cycle. The cycle you're going to see will play out like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with the oven. Now, after the workpiece has been processed by the oven, it is then sorted by color in the sorting line with color detection before being again moved by a vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've already discussed the components of each model previously, I won't belabor it by restating them here. But what I do want to mention are the dimensions of this model as a whole. Now, as it again combines all 4 of these individual workstations into one cycle, it does have a much larger footprint of approximately 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, depending on whether we're talking about the 24-volt version or the limited edition 9-volt version. Now, due to these dimensions and due to the weight, please note that this model will only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models tend to be in very high demand, please anticipate a possible turnaround time of 3 weeks prior to any order for this model leaving our warehouse once it's been placed. Now, a few other things to note. First, this is currently available in the standard 24-volt version and in very limited quantities in a 9-volt version. Now, in the instance of the 9-volt version, it's wired to 5 robotics TXT controllers, and because of this, it's going to require 3 120-volt power adapters. This is because a couple of the controllers are daisy chained, so we only need 3 power adapters. But as always, the 24-volt version will require the end user to provide any PLCs, any programming, any wiring, any additional hardware that's required. Again, each station of the 24-volt version does have the relay board for motor polarity reversal and both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the 2 factory simulations we just discussed who need to transport the model or who want to protect it when it's not in use. Now, the travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion of the case is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case itself has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of approximately 53 pounds. Please note, though, that even when using the travel case for your fischertechnik factory model, these models will still need to be shipped and stored flat. So you don't want to put them on their side, not like the case is showing you, unfortunately. Moving right along, the next model is a basic conveyor belt. Now, this is a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyors can be connected to increase the length of transport as desired. Components on this model include an excess motor, a push-button limit switch, 2 phototransistors, and 2 LED light barriers. Dimensions of this model are approximately 14 by 10 by 4 inches, and it has a weight of just about 2 pounds. Now, as before, the standard 24-volt variation includes a multi-pin connector, in this case 26 pins with a 2.54 millimeter grid as seen here. And for a limited time, we also offer a 9-volt version pre-wired to the robotics TXT controller as you see in this picture. In this case, one 120-volt power adapter is required for operation. The next model is a variation of the conveyor belt, which includes a punching machine. Now, this features, again, essentially the same conveyor as we just looked at, except this time with a machining station built into it. Components on this model will include 2 excess motors, 2 push-button limit switches, 2 phototransistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches, and it has a weight of just about 3.5 pounds. Again, this is available in a standard 24-volt variation with a 26-pin connector, a 2.54 millimeter grid is shown here, and for a limited time, we are still offering a 9-volt version wired to the robotics TXT controller, which does require one 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. And this model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts I just touched upon, 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. The dimensions of the model as constructed are approximately 19 by 18 by 11 inches with a weight of about 8 pounds. Again, it's available in both the standard 24-volt version with a 26-pin connector and 2.54 millimeter grid for use with PLC. And it is available in a limited release 9-volt version wired to the pre-programmed robotics TXT controller and does require one 120-volt power adapter. Next is a variation on the idea of a pick-and-place robot, which is called the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for this robot are as follows. Axis 1 turns 180 degrees, axis 2 can move forward or backwards 90 millimeters, and axis 3 can raise or lower 150 millimeters. Components on the model include the 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of this model are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. Again, this comes in either a 24-volt version with the 26-pin connector and a 2.54 millimeter grid designed for use with the PLC and the programming of your choice, or in a 9-volt version, which in this case is not a limited availability item, but is a standard model. And again, the 9-volt version comes pre-wired to a pre-programmed robotics TXT controller, and it does require one 120-volt power adapter. Now that concludes our look at the first 9 variations of simulation models. The next area of simulation models we're going to look at focuses on the area of IoT and is designed specifically for demonstrating and teaching about cloud-based monitoring and control. These models go by the name of Training Factory Industry 4.0, and these are available in both 24-volt version for use with PLC and 9-volt variations for classroom and demonstration purposes. Now, they've been designed to help address how the recent changes in industrial production, which are driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a larger scale. Now, as the following video showcasing the 24-volt version provides a nicely narrated overview of how this factory works and the various components, I'm going to step back for a moment and allow you to watch and listen to the narrator.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. The sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first in, first out.
Oh. Hang on.
The principle applies to outsourcing.
Sorry about
The
that.
goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The FischerTechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Well, I hope that answered some questions for you. Let me just provide a little bit of a summary of some of the things mentioned during the video. Now, the following topics can be addressed with the FischerTechnik Training Factory Industry 4.0. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features not found in the models that we've previously discussed, besides just most notably the use of a cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera attachment, which is used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, enables the positions of each piece in the work cycle to be mapped. And the use of MQTT, message queuing telemetry transport, allows the network TXT controllers to communicate with one another in the 9-volt versions. Now, as there are 2 variations of this model, let's go over what makes them different aside from the voltage requirements. And we're going to begin by focusing on the 24-volt version and what makes it unique. First, it's a bit of a hybrid in that while requiring a PLC for all operations and control, it also incorporates one FischerTechnik's robotics TXT controller. The TXT controller serves as the MQTT broker and interface to the FischerTechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. Now, in addition to the TXT controller being used here, there is also an IoT gateway using Raspberry Pi with Node-RED. Now, this allows the option for not only presenting and using data on a dashboard in the FischerTechnik cloud, but also to be able to display data and calibrate stations of the factory in a Node-RED dashboard if you chose. Now, the model also incorporates newly developed 24-volt adapter boards to interface with the PLC. These, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, also known as pulse width modulation, and they also have push-pull output stages for phototransistors and for buttons. Finally, one of the most important new features. Now, unlike any of the previous 24-volt models that we've discussed up until now, the new 24-volt Training Factory Industry 4.0 also includes access to a sample program. This program, in structured text format, was created based upon a Siemens S7 1500 PLC, and this is available for download on GitHub. Now, of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program. And if you wanted to do this, the source code needed is also available for download from GitHub. Now, as with the first of the 24-volt models that we looked at today, each of the workstations of the 24-volt variation of the Training Factory Industry 4.0 model have a relay board for motor polarity reversal in both the multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, along with PCB terminals with pushing connections for all inputs and outputs. Now, all of this information, much more, is included in the detailed 152-page PDF manual, which can be downloaded from the fischertechnik website, or if you want, I will be happy to email you a copy. Just simply request it from me. I'll give you information on that at the end of the program. Now, in the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all other 9-volt versions we've looked at previously today, in this case, these are programmed not using RoboPro, but instead using C, C++. Again, all of the programming is preloaded so that once connections to the internet and the cloud-based dashboard are made, all of which is clearly outlined in the downloadable documentation PDF for this model, which is also available upon request if you want it, you should be able to get started quickly. The 9-volt version will require the addition of 3 120-volt power adapters. Of course, both these models require the ability to access the internet, as well as a tablet or a device for accessing a cloud-based dashboard. The dimensions for the models are approximately 39 by 31 by 16 inches. They have a weight of between 51 and 53 pounds each. And as with the 2 factory simulation models that we discussed previously, we do recommend the optional travel case to help protect your model during travel or storage. And that essentially is the Training Factory Industry 4.0 model, again, available in both 9-volt and a 24-volt variation. Of course, you might well be wondering how much these models cost. So we're going to take a quick review of each option I've discussed along with pricing for each. The first version, the vacuum gripper robot, is available currently in the 24-volt version. It's $1,010 each. The 9-volt version is currently not available. The automated high bay warehouse, the 24-volt version, is available for $1,159 each. The 9-volt version is $1,319 per unit. The multi-processing station with oven in the 24-volt version is $1,010. The 9-volt version with the TXT controller is $1,479. The sorting line with color detection in the 24-volt version for use with PLC is $840 per unit. The 9-volt version is $1,129 per unit. And the full factory simulation in the 24-volt version is $4,369. And in the 9-volt version is $5,239 per unit. Of course, the 24-volt versions that we've discussed up until now, you need to provide the PLCs, the programming, the wiring, any other hardware. Next up, conveyor belts. 24-volt version is $252 each. The 9-volt version is $519 per, of course, includes the TXT controller. The punching machine with conveyor belt in the 24-volt version is $336 each. In the 9-volt version is $599 each. The 3D or 3-axis robot in the 24-volt version is $909 per unit. In the 9-volt version, you're looking at a list price of $1,219. The indexed line with 2 machining stations in the 24-volt version is again $909, and in the 9-volt version is $1,399. And the full Training Factory Industry 4.0 in either the 24-volt version for use with PLC or the 9-volt version that comes pre-wired to the robotics TXT controllers. In either of these cases, you're looking at a cost of $8,235 per unit. But there's more, as they say. There are 2 new variations of the factory simulation, the 24-volt factory simulation, which are now available. First one is with the PLC connector board. This will include all of the wiring and the board that the PLC itself actually plugs into. So basically what you need to provide here is the PLC itself. So it's got the rest of the things, the power supply, what have you. You are looking at a cost currently of $11,088 per unit for one of these with the PLC connector. If you would like the PLC included, there is now an option that includes the PLC. So essentially this is as close to a plug and play option as there is currently available. So this is going to have the factory model, all the wiring, it's going to have the PLC, it's going to have the programming, what have you. This again comes with the Siemens PLC S7 1500 PLC. If you are in the education market, of course, we require education verification. So this is colleges, universities, high schools, what have you. You're looking at a cost of $16,715 per unit. If this is for commercial use, for retail purposes, private use, what have you, you are looking at a cost of $18,900 per unit. Other items to touch upon, as I have mentioned it several times throughout the presentation, the 120 volt power adapters that are used for the 9-volt models, and in the case of the 24-volt models that do have the TXT controller, you need to get one of these as well. You're looking at a cost of $12.99 per. And for the travel and storage case that's used for the factory simulation and training factory industry 4.0 models, you're looking at a cost of $13.99 per unit. So at this point, if there are any questions whatsoever, I would say use the Zoom chat window or the question window, either of which, if you just feel free to type in any questions you may have. If I don't see any writing or anything going on, I will probably just move things along. So going up, is there a lead time on any of these items? Yes. As I mentioned, in general, I would plan ahead for a 2 to 3 week turnaround right now. Actually, we're probably just getting over the worst time of the year, which is always the beginning of January, because traditionally Fischertechnik doesn't ramp up its production until the second week in January after the holidays. So they're at work on all of that right now. But in general, I would say, you know, send me an email. I'm going to provide my email address in just a minute. If there's any particular items you're looking at, I can give you an idea of what's actually in-house as of right now. But in general, like I said, especially with the factory units, anticipate a 2 to 3 week turnaround to be safe. Will you email you a brochure? Actually, yes, I will send you, I'll give you the link so you can email me so I have your contact info, and I'll be happy to send you something. So on that note, if you would like to take the next step, so if it's doing something like you just asked about, requesting a full color brochure and current pricing, if you'd like to ask me any questions directly, if you'd like to request a quote, if you'd like to speak with your dedicated educational representative, or if you're in the commercial sector, if you'd like to speak with myself, you can call us here at Studica US. The number toll free is 888-561-7521. General inquiries about Fischertechnik and all the industrial simulation models, you can email us at info@studica.com. Anything special for me, you can email me at lance.zurek, lance.zurek@studica.com. On that note, thank you very much for your time and for taking the time to attend today. We hope you have a great day, and we look forward to hearing from you soon. Take care.